Okay, question 5, part A. Figure 5.1 shows a simple AC generator being tested by electrical engineers. There's the magnet rotating around a fixed coil. The coil is attached to an oscilloscope. It consists of a magnet on the shaft of a variable speed motor, so we can adjust the speed of the motor, being rotated inside a cavity of soft iron core. The output from the coil wound on the iron core is connected to an oscilloscope. Okay, we're going to need to remember how to use an oscilloscope, which is PAG 5.3, by the way. If you need to repeat PAG 5.3 just to regain your familiarity with using this device, you should do it. The grid of figure 5.2 shows a typical output voltage which would be displayed on the oscilloscope screen. So a typical oscilloscope would have a voltage as the y-axis and time as the x-axis. This would be little centimeter blocks, and you would have a dial that would adjust what each centimeter is worth in terms of voltage on the y-axis, and a dial called the time base which adjusts what each centimeter is worth on the x-axis in seconds or milliseconds. According to Faraday's law, so Faraday's law is that the induced EMF is equal to the rate of change of flux linkage. According to Faraday's law, the EMF induced is directly proportional to the rate of change of flux linkage. In the context of this experiment, the maximum EMF induced is directly proportional to the frequency of rotation of the magnet. Okay, that makes sense. I've derived this particular equation many times. I hope you have too. If you haven't, do put it to some practice. Epsilon max is 2 pi FNBA. So this is suggesting that the maximum induced EMF is directly proportional to the frequency, which, provided 2 pi N, B and A are kept constant, would be true. So epsilon max proportional to frequency of rotation. Perfect. Everything makes sense so far. Use the apparatus above, so that means an oscilloscope and this variable speed motor attached to a magnet rotating inside a coil. Use the apparatus above to plan an experiment to validate Faraday's law of electromagnetic induction. In your description, include how the data is collected and analysed. So this is your typical 6-mark practical skills question. Let me just check how many marks this is out of. 6 marks. Lovely. So the usual routine is, what are you going to measure? What are you going to measure it with? Any calculations and extra pieces of information associated with this experiment, and then suggesting a graph which will hopefully be a straight line graph with a gradient mean something. So let's take some of this space up here to brainstorm a couple of ideas. If I write the equation in this format, epsilon max, so maximum induced EMF, equals brackets NBA 2 pi, close brackets, open brackets, F. I've written it that way. I suppose I should write it maybe possibly NBA 2 pi 1 over T, because that would be my raw piece of data in this experiment. But 1 over T is the same as frequency, so frequency I don't think is considered a processed piece of information in this case, so I'm quite happy to plot frequency on the x-axis in this particular case. And then this would be y equals mx plus c. So if I were to plot frequency on the x-axis, different frequencies on the x-axis, and plot on the y-axis the maximum induced EMFs, that should hopefully produce a straight line graph that goes through the origin, doesn't have a y-intercept or x-intercept at all, where the gradient of the line would be equal to 2 pi NBA, and these would be my control variables. So that would be a constant, something that needs to be kept constant, something that needs to be kept constant, and something that needs to be kept constant. So control variables there. My independent variable, my dependent variable, so the sort of table that I would be looking to record would be, I suppose, reading from the oscilloscope. One of my raw pieces of data would be 1 full cycle. This here would be the time period t, and this here would be my epsilon max. So really what I'd need to do is record my time period in seconds, my epsilon max in volts, and possibly my frequency of rotation in hertz, which is just going to be the inverse of the time period there. So everything's set up now for me to start writing what I would do. Now any self-respecting graph needs at least 8 points. So I'm going to jump on the fact that this variable speed motor bit, this variable speed, is highlighted in bold. And I'm going to suggest 8 distinctive different speeds. I don't know what they're going to be. I'm not going to decide in advance what they're going to be. I'm just going to look at the full range of the speeds of the motor, and I'm going to go slow, medium, medium fast, fast, but I'm going to try and get 8 different speeds there. So I'll communicate that as follows. Set the variable speed motor to 8 different speeds from slow to fast. For each speed setting, use the oscilloscope to measure the period of rotation t from the x-axis and the peak EMF from the y-axis. Now as the picture is here, and as I've sort of graph graffitied it with epsilon max and capital T, I'd probably jump on this opportunity to show how I understand how this oscilloscope works. So this would be a peak EMF of 1 centimeter, and 1 centimeter would be worth a particular number of volts depending on what the dials are set to on the oscilloscope, and the time period would be 4 centimeters space on the screen, each centimeter representing a particular time depending on what the time-based setting is on the oscilloscope. Say again, if you need a reminder or a refresher on how to use an oscilloscope, take the opportunity before you take the exam. In the picture above, the time period is 4 centimeters times whatever the time-based setting is set to in seconds per centimeter. And epsilon max, the maximum induced EMF, is equal to 1 centimeter, up there, 1 centimeter times by whatever the y-axis setting is set to on the oscilloscope in volts per centimeter. Full stop. Use the equation frequency equals 1 over the time period to calculate the frequency of rotation of the motor, and record time period, frequency, and maximum induced EMF for each of the 8 motor speeds on a table. Maybe we can just sketch a table to illustrate what you mean. Plot a graph of maximum induced EMF on the y-axis and frequency on the x-axis. Take the time to illustrate with a little picture. If Faraday's law is correct, this will produce a straight line graph which goes through the origin, 0, 0, as in no intercept. Take the time to illustrate what that looks like. Where the gradient of the line is equal to 2 times pi times the number of turns times the magnetic flux density times the cross-sectional area of the coil, which are all constants or control variables in this experiment. Take the time to illustrate that up the top here. Gradient equals 2 pi NB A. Job's a good one.